All right, what's going on? I'm Jacob Rose.
I'm Liam Hogan.
This is our final project for the business for math class, the math for business class. So today we're going to be talking about linear programming, in particular the maximization with the simplex method. This is topic 10. And so we're going to give you just a minute of some background knowledge about it, and then we'll get into how to solve some equations.
Alright, so it is a method to achieve the best outcome, such as a maximum profit, or in a different case, a minimum cost, in a mathematical model, and the requirements are represented by a linear relationship.
As Liam mentioned, it's used a lot within business to see how you can maximize your profit, find the lowest cost of something, make sure you're allocating the right resources to the right places. So yeah, that's a little background of it. Obviously, we're not going to be finding maximum profit today. We're just going to be running through some equations for you. So teach you how to do it. We're going to go step by step. We'll give you a real world application as well as just a numerical one. And hopefully by the end of this, you'll know how to do this too.
Yeah.
So let's get into it.
Let's go.
What's going on? Jacob Rose, student here at Lebanon Valley College, and today I'm going to be showing you the numerical version of linear functions using the simplex method. So over here, we're going to be trying to maximize this equation. So we have p equals 5x plus 4y, and down here we have all the constraints right here. And so the first thing we're going to do is we got to make all of these equations, all of these inequalities equations. So we're going to use that by using slack variables. So we're going to change this into 3x plus 5y plus, let's say u is our slack variable for today. And we're going to plug in that 78 there. And we're going to do the same thing for this line as well. Plus y plus, let's go L as the next slack variable. And then we don't have to deal with this because this is just x and y parameters. However, up here, we got to make this so that when we equal it to p, it equals to a positive number. So that's going to turn into this. We have smarter shot. How to block up here? Okay. We're gonna write it like this, or we're gonna go. Oh, that's so much better. Minus 4y. We're gonna say plus. Let's go m for this one. Is equal to 0. All right. So it's first. All right, we're back for step 2. So now that we have all the equations written out, we can put them into our chart. We're going to be using this chart the whole time. We're going to do it multiple times. You're going to see later on in the steps. So I already have the chart written out. This is all your variables. So x, y, ulm, x, y, ulm corresponding to the ones up here. And then I already plugged in the first line. Basically all I'm doing is I'm just taking these numbers and plugging them into the equation. So I'm going to do these two equations and then the maximization equation. So let's see, as I explained, these are where the variable numbers come from. So 4x, we're going to put 4 right here, just a 1 for the y, and then no u because there's no u, so we're going to put 0 there. There's 1l, so we'll put a 1 there, and then put 0 here, and then obviously equals to 36. And now we're going to do the same thing for the maximization, but we're going to do it down here. So we got -5, -4, we got a 0, we got a 0, and then a 1. And the reason that these two are negative and this is positive, I think I explained it in the other clip, but I'm going to explain it again, is because we want the value of m to be positive. And then we're going to set that equal 0. All right, we're back. Step 3. So our next step is to find the pivot point. So that's where we're going to start. So to do that, we're going to look at the objective or the maximization line in this case, and we're going to find the most negative number, which in this case is going to be this row. So we're going to have the x column over here. Now, the way we're going to find the row is we're going to take this number, so whatever digit is in the X column, we're going to divide it into this column right here. So pretty sure it's equal to 26, and I'm pretty sure this is equal to 9. So yeah, and so we're gonna, for this one, we're gonna take the smaller number, so our row, our pivot row is going to be here, and so this is going to be our pivot value. All right, so the next thing we're gonna do now is use row operations to make this number a 1, so our pivot value 4, which I conveniently wrote up there for viewing pleasure. So we're gonna do that by, we're gonna divide this whole row by 1/4 row 2, because this is row 2, and then we're gonna divide it by 1/4, which makes this 1. So we're gonna get on my knees down here. We're gonna rewrite this really fast up here. So we have the same numbers up there because we haven't done anything to those yet. And then this is where this changes. So we get 1, 1/4. We get 0. We get 1/4. And then we get 0. And then down here we get same numbers. And this will equal 26, 6, and this will equal to 9. And so now what I'm going to do is I'm going to do the same process for both of these rows. And when I'm done with that, they'll be right here. So, all right, I'm just finishing up writing down the rest of these on here. So obviously I did this math off camera, but you can do it. You just plug it into a calculator. You just plug in this down here and then get it up there. So now what we're gonna do is we're basically gonna do the exact same step as over here again to keep it going. So we're gonna find the one with the greatest negative. So this row. The difference is we're gonna be doing it on the Y column and not the X column, so we can find X and Y values. And then we're going to find the smallest one, so we're gonna divide this into here, which is equal to 12, and then this is equal to 9. And so out of these two, obviously this is the smallest one, so this is going to be our pivot element again. It's going to be this 1/4. All right, so now that we got this all set up from this, I just did the math. We're now going to go on to the second step to get the Y value. So we're going to do it from the Y column this time, and we're going to divide these numbers as we did earlier. We literally just did this. So we're going to divide these numbers into these numbers again. So this is going to equal to 12. This is going to equal to 36. And so now we have to find the pivot value again because we're doing the same steps over. So since this is the smaller number, I'm going to circle this row, and there we go. So 17/4 is going to be our pivot value. All right, so now that we have our pivot value, we're going to start doing what we did over here again. So we got to make this a 1. So we're going to divide the first row. So row 1, we're going to multiply that by 4/17 because that's the same thing as dividing by this number. So we're going to make a new chart down here really fast. And then we're going to write out all of it. So it's going to be 0. It's going to be 1, obviously. It's going to be 4/17. It's going to be 3/17. It's going to be 0 over here, and then it's still going to be 12 over here. And now I'm going to do that for the rest of these rows, and I'll be back with that. All right, we're back for the final step. So now that I've equated everything, the equations I used are on the left here. We're going to figure out the answers. So to find whatever the variable we're looking for, you're going to look for which row has the only ones and zeros in it. So as you can see, we have the x, the y, and the m variables only have zeros, and then we look for wherever the 1 is, and that's going to be a variable. So for x is going to equal, so here's the x row, we got the 1 here, and we equal to 6. Going to do the same thing for the y, so we got the y, 1's up here, go to 12, and then we got the m is equal to 78. And you just kind of don't pay attention to these because they have to be 1 or 0 because of the constraint. So yeah, as you can see on the right side, here are the variables, the answers to the maximization of the equation above. And yeah, I hope this was helpful, and I'm going to pass it on to my teammate Liam, and he'll show you a real world example.
Hi everybody, I'm Liam Hogan, and I have a real world application for the simplex maximization method. So Nikki holds 2 part-time jobs, job 1 and job 2. She never wants to work more than a total of 12 hours a week. She has determined that for every hour she works at job 1, she needs 2 hours of preparation time, and for every hour she works at job 2, she needs 1 hour of preparation time. She cannot spend more than 16 hours for preparation. If she makes $40 an hour at job 1 and $30 an hour at job 2, how many hours should she work per week at each job to maximize her income? So, for step 1, you want to make your equations, right? So you have your maximization profit, your maximization equation, and then you have your constraints. So you don't want to work more than 12 hours. She doesn't want more than 16 hours of preparation time, and everything has to be more than 0. So now, what you're going to do is you want to turn all of these into equations. So you have the slack variable of z, y1, and y2. So you turn all of these into equations, and then after that, you're going to plug in each of these into your Tableau. So right here, as you can see, we have 1x1, 1x2, 1y1, and then 0 y2s and 0 z's, and then 12. So you're going to do the same thing by plugging all of those in to the equation, so on and so forth. Then we want to find our pivot point. So you want to go to your most negative number, which is 40. Most negative number in the bottom row, which would be 40. And then you want to go up and you want to divide each of these. Well, you want to divide each of these numbers here by these numbers here. So 12 divided by 1 would be 12, and 16 divided by 2 would be 8. You want to go with the lesser of those 2 numbers. And the intersection point there would be your pivot point. So we're going to go with 2. All right, after that, you want to multiply your second row. Well, you want to get your pivot point to be number just 1. So you're going to multiply the second row by -1 and add it to row 1. So we're multiplying 2 by -1 to get -2, and then adding it to row 1 to get 1. So that's what we get here. All right, multiply by -1, add it to your row 1. After that, this is what we see, and you want to multiply the second row by 40 down here, because we're trying to get this to be 0, and add it to the last row to obtain 0 below the pivot point, as you can see here. So we multiplied the entire bottom row by 40 and added it to that row. All right, so you can see we have the values of -10 now, or 20, and 320. All right, that's basically the step, but now we're going to do it again because we still have a negative number in the bottom row. So you want to find your most negative number, and that's the column you want to be in. And then you go up and you multiply, or you divide these 2 numbers by these 2 numbers. So in this case, this would be the lesser of the 2 numbers. So after that, you know that this is your new pivot point, and we're basically just doing this all over again. So after you do that, you want to make this equal 1, just like there. So we are going to multiply row 1 by negative 1/2 and then add it to row 2. So that you can see that here. And then our pivot point, sorry, I didn't circle that, is now going to be 1. After that, you want to multiply row 1 by 10 and add it to our last row to get this to be 0, because you want to eliminate that negative number. So you do that, and then that's what we can find here. So basically we're done with all of the math now. You just want to find the rows that have 1 in the value and then 0 for all other values. I don't know if you can really see that, but I wrote that out in green here. So x1 has 0, 1, 0, x2 has 1, 0, 0, and z has 0, 0, 1. Then our c values over here are 8, 4, and 400. So then basically this chart here is saying that if Nikki works 4 hours at job 1 and 8 hours at job 2, she's going to maximize her profit of $400. So then our equation right here is our maximization profit. No, our maximization equation.
He starts off.
Thank you.
Thank you for watching.
Hopefully you learned something new, or not new. Hopefully you learned something that we already knew.
Thank you for a great semester, Professor Choi.
Thanks, Professor Choi.
Yeah, have a good one. Sweet.